Now we've looked at the part of the skull that we're concerned with in this section. We'll move on now to look at the bones below it. First, we'll look at the special features of the first two cervical vertebrae, the atlas and the axis. Then we'll look at the continuity of the cervical spine with the bones of the upper part of the trunk. Here's the atlas, here's the axis. These two vertebrae are adapted to allow movement of the head. Forward flexion and extension of the head take place up here at the atlanto-occipital joints. Lateral flexion of the head takes place at these joints too. Rotation of the head, together with the atlas, happens here at the joints between the atlas and the axis, the atlanto-axial joints. Because of their special functions, the atlas and the axis differ in several ways from typical cervical vertebrae. As we've seen in Volume 3, a typical cervical vertebra has a body in front and a neural arch behind, enclosing the vertebral foramen. It has a spinous process behind with two tuberosities and a transverse process on each side, also with two tuberosities. On each side there are two articular surfaces, one above and one below, which form the intervertebral joints. The articular surfaces slope upward and forward. They are connected by this mass of bone, the articular pillar. Each vertebra is joined to its neighbors by an intervertebral disc in front and by two intervertebral joints behind, one on each side. Now let's look at ways in which the atlas and the axis are different. The atlas vertebra doesn't have a body. In front, it just has this narrow anterior arch, which matches the posterior arch. The two arches of the atlas, together with these two lateral masses, enclose an unusually large vertebral foramen. This part is occupied by the spinal cord, this part by the odontoid process of the axis, which we'll meet in a moment. The upper articular surfaces of the atlas are shaped like parts of the inside of a cup, to match the shape of the occipital condyles. The lower articular surfaces of the atlas are shaped like parts of the inside of a cone. Now let's look at the axis vertebra. The body of the axis is prolonged by this important projection, the odontoid process. In terms of development, the odontoid process represents the missing body of the atlas. In terms of function, it's the pivot around which the head, together with the atlas, rotates. The upper articular surfaces of the axis are placed well in front of the lower ones. The upper surfaces are in a straight line with the odontoid process. As rotation occurs between these surfaces and those of the atlas, the odontoid process stays in the middle. The odontoid process is surrounded in front and on each side by bone. It's held in place behind by a strong ligament, the transverse ligament of the atlas. The odontoid process is also held in place from above by two strong ligaments, the alar ligaments, which are attached here and here. We'll see these ligaments shortly. The odontoid process has two small articular surfaces, one behind for the transverse ligament and one in front for the anterior arch of the atlas. To see how these structures relate to the base of the skull, we'll take an inside look from behind at a specimen in which the neural arches and the back of the occipital bone have been removed. Here's the foramen magnum. Here's the inside of the basal part of the occipital bone. Here's the atlas. Here's the axis. Here's the odontoid process. Here are the atlanto-occipital joints and the atlanto-axial joints. Now that we've seen the atlas and the axis, we'll look at the bones below them that are involved in support and movement of the head. The lowest cervical vertebra, the 7th, articulates with the highest of the 12 thoracic vertebrae. The 2 first ribs slope downward and forward from the first thoracic vertebra. The costal cartilages of the first 2 ribs articulate here with the upper part of the sternum, the manubrium. The manubrium, the first ribs, and the body of the first thoracic vertebra form the margins of this opening, the superior thoracic aperture, through which many important structures pass. To complete our picture of the bones in this section, we'll add the clavicles and the scapulae. On each side, the clavicle articulates with the highest part of the manubrium to form the sternoclavicular joint. The sternocleidomastoid muscle is inserted here. The scapula is attached to the clavicle here, at the acromioclavicular joint. In addition, the scapula is held in place by powerful muscles, the highest of which, the trapezius, arises here on the skull and is inserted here. Now let's move on to look at the ligaments that connect the skull and the cervical vertebrae. Like ligaments elsewhere in the body, these structures hold the bones together, permit the bones to move in relation to one another, and set limits to their movements. We'll look first at the structures that permit movement between individual vertebrae, the intervertebral discs and the intervertebral joints. Then we'll look at 3 ligaments that run the length of the cervical spine, the nuchal ligament and the anterior and posterior longitudinal ligaments. Lastly, we'll look at the special ligaments around the odontoid process. Here's what the cervical spine looks like in the living body. Here are the spinous processes, the articular pillars, the transverse processes, and the vertebral bodies. The intervertebral joints are here. They're synovial joints. To get a better look at them, we'll make a cut through the articular pillars along this line. As with all synovial joints, each bony surface is covered by a layer of smooth articular cartilage. The space between the cartilages is filled with lubricating synovial fluid. The fluid is contained within a fibrous joint capsule, which permits movement. Between each vertebral body and its neighbor, there's an intervertebral disc. To see the discs, we'll make a cut in the midline. The discs are made of fibrocartilage that's attached firmly to the vertebra above and below. The fibrous joints formed by the discs permit only a little movement between the regular cervical vertebrae. The movements that can occur between these vertebrae are forward flexion, extension, and a twisting movement that's a combination of rotation and lateral flexion. In the intervals between the occiput, the atlas, and the axis, where so much movement occurs, there are no discs, only synovial joints.